Hello again, everybody. This session, everybody, is from Krishna Chaitanya Telikicherla. Hope I got somewhere near correct on that. And Krishna is a senior security engineer at Microsoft, where he is a member of the Azure Edge Serpent team. He specializes in application security and performs security assessments against Azure EDG software products and services. He is passionate about discovering and eliminating code-level vulnerabilities at scale, and loves exploring security and identity controls of cloud services. He blogs at novogeek.com and tweets as novogeek. With that, I will turn it over to Krishna to talk to us about common vulnerabilities in modern Auth implementations, which is directly relevant to work I've just been doing, and I look forward to this. Thank you.
Excellent. So thank you so much for the intro, Brian, and hello, everyone. Welcome to this talk. So in this talk, what I'm going to do is I'm going to present about 5 common OAuth vulnerabilities that we see in our pen test. Of course, these are the findings that we have discovered internally in our pen test at Microsoft. We've reported and they're fixed. So then we thought it will be a great idea to share this with the wider OWASP community. To be clear, this is not new research. The guidance for preventing and fixing these vulnerabilities is written clear, and it's there in Microsoft Docs and documentations by other enterprises as well. So these are mostly unintentional and less obvious mistakes, like configuration and code level mistakes done by developers. And so if you're into OAuth space, I think pretty much these will be very basic. If you're into if you're really into OWASP, like OAuth space and trying to do authentication protocols and stuff like that. But if you're not into OAuth, some of the demos and some of the things that I'm going to show could be a little complex, but don't worry. I have a lot of animations and a lot of demos, and I'll try to simplify it as much as possible. And of course, since the session is being recorded, probably you'll be able to get it when you look at the demos. So I think with that context, let me get started. Yeah, so this is a fancy slide that I made, but I think Brian did a great job in explaining about my background and what I do. So yes, in a nutshell, so I'm from the Serpent team at Microsoft, and we do offensive security assessments. So we do red teaming, purple teaming, application security. And yeah, excited to talk about what we are doing. And I think I have a last slide where I'll talk more about our team. But with this, let me really move on to what is the core topic that I'm going to talk. So firstly, when we talk about modern Auth vulnerabilities, let's talk about what is modern Auth scenarios, right? So on this slide, you see different kinds of scenarios, like scenarios where users are involved, scenarios without users. So what are these scenarios? So in the current web world we are living in, these are the kind of interactions that we are really having. Like we have web apps and single page apps, the new style of web apps. And then we have mobile apps, desktop apps, browserless apps, your IoT devices, and then backend serverless apps and daemons. All of these, they need to talk to APIs, right? So APIs have become the heart of the entire modern web, and they need to talk to them in a consistent way, in a secure way. I mean, if we were talking about how this could have been possible a decade ago, I think we can clearly envision, we can clearly see that there could be a lot of fragmentation. But thankfully, the whole web and the protocols have evolved a lot, and today there's a lot of consistency and there's a standardization of how these can interact with each other. Now, these are the scenarios from a user-centric standpoint. We are not even talking about cloud-native services or cloud-native architectures or microservices, right? I mean, of course, those are complex architectures that are built on these basic primitives. So from a user standpoint or an interaction standpoint, these are the scenarios that we are dealing with. And how do we get it done in a secure fashion? So that is the whole point, right? So now, thankfully, we have OAuth 2.0 and OIDC, OpenId Connect. So these are the 2 protocols that have become the backbone of the modern web. And OAuth 2 is an industry standard authorization protocol, and OpenID Connect is an authentication protocol built on top of OAuth 2. Now, I'll not be able to do a deep dive of these protocols and flows because of obviously of the time constraints. Now, the talk assumes that the audience know a bit about OAuth. I mean, either through writing some code or through pen tests or through interactions, or at least through architectural discussions. And now, if OAuth is completely new to you, probably a little reading on that would have helped earlier, but that's still fine. I think since it's being recorded, we have the opportunity to go back to brush the fundamentals and come back. But I'll try to, as much as possible, I'll try to explain the little nuances without diving too deep into the protocol level handshakes. But at a high level, in OAuth 2 and OIDC, we are talking about 4 parties: resource owner, client, resource server, and identity provider or authorization server. Now, we saw earlier cases where there are cases where clients have users or they may not have users. So when we talk about clients, we're talking about browser clients, mobile apps, and stuff like that. So they need to talk to a resource. What's a resource? It could be an API or your images or photos on a server, right? So those are the resources. Now, clients need to talk to authenticate and get the resources, authenticate and authorize. Now, how do they do it? By talking to an authorization server. So the clients talk to authorization server, get something back known as a bearer token, and that's what they send to the resource server. If users are involved, users enter the credentials. Otherwise, it will be without user interaction. So that is pretty much a high-level gist of OpenID Connect and OAuth. Now, there are a lot of flows, obviously the authorization foreground flow, implicit flow. I'm not going to dive into those details here, but I think I'll show some of the problems. I'll talk about what those problems are. So the way how I try to do this is that, okay, so if I can do it, a verbal way, saying that, hey, here is a problem, here is a guidance, go fix it. But then I thought it's interesting to try to demonstrate and try to exploit it. So let's see if the demo goes with me. I think let's see with some interesting demos on how these can be exploited. Now, what are those vulnerabilities? So these are the things that we're going to talk about. But first, let me take a very basic scenario, which is a simple enterprise user using a web browser and trying to access a web API. Right now, like I showed a couple of slides ago, there are several scenarios that are feasible, and it's not practical or not possible to talk about to demonstrate all the possible scenarios. So I thought let's take a very simple single page application, because that is the most common things that we see across. So then we have this identity provider. So when users try to visit a browser and access a single page application to hit the API, they get redirected to identity provider, where users authenticate, and they get back an access token, which they pass to the web API. Now, there are a lot of nuances in this handshake that I'm deliberately ignoring. Like, for example, I'm not talking about ID tokens, refresh tokens, and things like that. A very basic scenario: users authenticate. There's a federation happening here. So users are taken to identity provider, and they get back access token through the browser, and that's sent to the API. And that's how users authenticate and authorize to the API. Now, before I explain about vulnerabilities, one thing I would like to call out. In this whole talk, I'm going to use Azure AD as the identity provider and ASP.NET as the web application. Now, of course, there are different identity providers out there and relying parties. So, I mean, it's not possible to cover different tech stacks. So I thought I'll take the stack that I'm more familiar with. I understand that the audience who are looking at this right now, and probably who will be looking at this in the future, they may not necessarily be familiar with this tech stack. I sincerely apologize for that. But I think the key takeaways, I think as we go towards the end of the presentation, the key takeaways will be generic in most sense. And then I think they'll be applicable to most of the OAuth scenarios. So with that, what are the problems here, right? So, I mean, so before again, I think let me repeat, the base scenario we're talking about here is a single page application, user accessing it, trying to authenticate with an identity provider, get back a token and submit to an API. Now, what can go wrong, right? So firstly, who can request tokens? Now, that's obvious. I mean, who can request tokens? Whoever are the users of that enterprise can request tokens. That could be the simple answer. Can there be some gaps there? Maybe. Let's see that. Where should the tokens be sent? Now, that's another interesting question. Where should they be sent? I mean, I expect the tokens to be sent to this API because that's what we want to access. Where else can they be sent, right? So that's something that we should be thinking about. Is the token's integrity intact? Now, what does that mean? Now, we are talking about this access token. Obviously, it's a cryptographically signed token. So someone is signing it digitally, and then which means the API has to validate it. Now, what happens if something is wrong here? Can it be tampered, right? Is a token issued by a tenant that I trust? Which is another interesting thought on, okay, so can there be cases where the API is hit with a token, which the API does not trust, right? Maybe. Let's talk about that. And then, is the token meant for my API? Now, that is another interesting thought. Now, can there be tokens that are not intended for my API, but issued to this API? Maybe, right? So these are the questions. Now, I'm not really talking about the vulnerabilities yet. I'm just asking, hey, have you thought about this? Have you thought about that, right? So now what we'll try to do is we'll try to answer these questions in a way, probably I'll try to show some code snippets, probably I'll try to show some demos. Let's see how we can answer this question and see what is the problem that we are trying to narrow down on. First one, unauthorized access to guest accounts. I'll talk more about this, what is guest accounts and things like that. Token theft via insecure reply URLs. Now there is this concept of insecure reply URLs in OAuth spec, and so let's see how that translates to when we implement it, right? So I think one key thing to remember: we are not talking about implementing OAuth protocol or OAuth spec. What we're trying to use here is identity providers which are already OAuth compliant. We are trying to use their libraries and their configurations to build a secure app, right? So now, which means most of the cases that in most of the demos that I'm going to talk about, there is this concept of secure defaults. I think in the keynote we spoke briefly about it. So there is this concept of secure defaults, and now can there be problems if those defaults are not really maybe if they are changed or something is done with them, right? So then on the integrity part, whenever we talk about integrity in general for application security, we are obviously talking about tampering. So can we tamper tokens? And this is a very, I think in many bug bounties, this is a very common report we see in several bug bounty programs, right? This fourth one is a token issued by a tenant that I trust? Now, there is this concept of cross-tenant attacks, which is scary. Now, I mean, I think the name probably hints something, right? So a token coming from a different tenant, not your own enterprise tenant. And so, and the last one, something known as app impersonation attacks. It is a confused deputy problem. So the name is coined by one of my peers internally, but I like the name, so I just continued with it. But so this is really a confused deputy problem, meaning now the API expects a token. It's not the token that is really meant for it. So there's some kind of confusion there, and maybe the API can be fooled to think that it's for this. It's actually for this API if certain validations are not done. Now, these are all generic concepts. These are the generic vulnerabilities that I'm going to talk about. I will pause here so that you can just quickly go through it. But I will try to, for each of these cases, and then I think in the next 45 minutes, I'll try to show some animations and demos on what is the problem, how it can be fixed. And that is the whole agenda of this talk. Pausing here for a minute, I'll take the questions at the end because we have 5 different scenarios to cover. But let's real quick look at these 5 things. Who can request tokens? Where should they be sent? Integrity of tokens, trusting which tenant it came from, and looking at whether it's for my API or not. Okay. Now, with that, let me talk about the demo environment that I'm going to use this. So I have this setup, which is a website, Editum Corp website, talking to an Editum Corp API. These are all fictitious companies that I'm going to show here. So this is a single page application talking to an API. This web app is protected by Azure AD, which has different users. This is the tenant that I'll be using for the demos. So if you see this tenant when I log in, so that means this is the tenant for the genuine website that we are trying to protect. And we have 2 kinds of users: employees and guests. I'll talk more about this a little later. And this is just for FYI. I mean, you need not really focus more on this at this point. We'll talk about this later. But there is this on the top screenshot here on the left. What you see here is the AAD apps, Azure AD apps. So in OAuth, when you're trying to do a handshake, you need to register apps, right? Clients and for the client and the API. So these are the different apps that I registered. For example, here you see Item Corp client is the AD app for this website, and Item Corp Planner API is for this API, right? So that's how the app here gets a token, submits submits to this API, and the API will try to validate the token. So that is how it all ties up. And these are the users that I have: a CEO, CTO, admin, guest, and a developer. So I'm just trying to create a simple, a simple scenario. And of course, I mean, not everything is always good. So we also have an adversary coming from a Fabricam tenant. So this adversary, the goal of this adversary is try to poke at this API and try to get access to this API, right? So maybe the adversary could also try to compromise these employees, like employees or the guests, right? So that could also be a goal. But eventually the goal is to access this API. So that is a scenario. Now, just take a few seconds to look at this. And I think you'll get habituated to this as we do the demos, but let's see. So firstly, who can request tokens? Like I said, a directory, in this case, Azure AD, it has users, and the users could be employees or full-time employees, right? And then we have guests. Now, what is this concept of guests? So at least in the Microsoft world, when we're talking about M365 and other suites, there is a concept of, when you share a document with users outside your tenant, you are in some sense inviting them into the tenant as like behind the scenes, you are actually inviting them into your tenant. So what that means is that these users, if the tenant policies are not configured properly, these users might have some privilege that might come as a surprise to you, right? Now, can these guest users authenticate and get a token to this API, right? Like imagine that someone having some public identities, they may or may not have multi-factor authentication. Maybe they are compromised, their accounts got breached, and maybe they are available on their password hashes, and the passwords are available and have been bond, and maybe, right? So you can understand where this is going. So when those accounts are compromised in some sense, can an adversary come through that, or can these identities themselves turn rogue and access your enterprise resources? That is the first scenario, and let's try to look at the demo, and let's pray for the demo gods that everything works. I have the setup. What I'll be doing here is I'm having this Burp community edition. I'll be trying to capture and replay some traffic here, and where is this? And I will be trying to log in here. So let's try to log in. So if some or all of this is a little fuzzy, don't worry. I think if you're coming here for OAuth for the first time, you might be a little confused, but that's fine. I think as you understand more of these demos, it'll be easy. Now, what I'm doing here is I'm trying to log in. Now, I'm here trying to be a little fancy and try to showcase this thing called WebAuthn. WebAuthn is another new latest protocol for passwordless sign-in. I'm using my UB key to log in into this portal. So I'm not using passwords. So I'm promoting WebAuthn and passwordless. So that's another thing I'm doing here. So let's see what happened. So I logged in as a CEO, and let's say there are some. So what is this portal? It's a very single page app. I have linked the source code for this. Well, this is a vulnerable portal. I've linked the original repo from where I built this at the end of the slides. So it's a simple to-do list where I can just add a task and it will just show up, edit task, delete task. But then I'm trying to build a story around it saying, hey, here is a CTO and leadership of a company trying to add some tasks here, right? So now this is some sort of sensitive information. It will be bad if unauthorized users either access this or try to tamper this or add new entries. So that is the threat model that we are talking about. Basically, this single page app is protected by a backend API, and maybe there are some gaps, some vulnerabilities here, because of which other identities can mess around with this portal. So that is the story. And now let's see what happened. So, okay, what can the CEO do? Or the leadership do? They can just say, add some tasks like this. The tasks show up like this, right? Now let me log out of this CEO with the CEO account. Cool, I've sent it out. Now let's try to see if we can do something else. Now, remember in the tenant, I have this guest user. So let me try to see if I can log in with this guest user as well. Now I've protected all my accounts with WebAuth, so I'll be using YubiKey throughout. Yep, so there you go. Because the tenant did not have any guest policies configured and things like that, now the guest user can see this contact information, and then maybe they can also interact with this information. So basically, this is a very simple point that we are trying to say here is, hey, now your enterprise assets, they're protected, but do you really know who can access it? If you're not careful about it, probably folks who you don't expect might have access to it, right? So it's a very simple concept. And once I think the key point here is that, I was actually surprised that many did not know about this problem. But once developers knew this problem, the fix is very simple, because developers are really in control of how they can do authorization. I think they are more equipped to do authorization controls once they know the problem. Of course, because right now I'm talking about Azure Ready, there are tons of ways how this can be done. Like you could do B2B policies, conditional access controls, and you could the multiple ways in which you can fix this problem. Now, without going into too much into that, let me try to see if I can show one way to fix it, and let's see if I can pick the wrong way, because I've seen that also happening. Now, what I'm trying to show here is an Azure Ready portal, and this is the client app that I'm trying to restrict access to the users. So what I'm trying to say here is that for that client AAD app, I'm now restricting access only to corp employees. If you see the members here, these are the employees. There's no guest user in this list. So what I'm saying is that, hey, let's make it available only to certain users, right? So that's what I try to say when I go and configure toggle that button. Okay. So now let's try to see what can happen. Let me sign out again. Okay, so let me try to log in again. There you go. So this error message is saying that, hey, your tenant administrator has configured some policy or the app developer. So then this account at the IDP login page itself is being blocked. Okay. So remember, so this guest user is blocked now. I'll show you why this is not really 100% accurate, because we'll come back with this guest user later in a later demo. But in a nutshell, what happened here is when in the Azure Ready tenant, when the users are accessing this API, we try to configure a policy, or we try to configure a property which said, hey, block the login for the app that is being used to hit this API. Okay, so basically there's a client talking to this API. We block the client app, but so I can't see the UI, and I'm blocked at the login page. But if in a way, if in some way we can get a token for this API, maybe we can hit this API. So we'll see in the later demos. But again, revisiting the problem, who can request? Don't assume that only if you are being protected by your tenant, don't assume that only your employees, full-time employees can access. If your policies are not configured properly, or if your API is not validating authorization checks properly, you can expect unexpected parties to visit and hit your API. So that is the key takeaway here. Now, if you're new into this AAD space, maybe this part is surprising, and maybe this is a little too much to take, but this is just the beginning. There are many more things. Let's then move on to other things. Now, this one, where should the tokens be sent? This one is another interesting thing that surprises many developers. Now, for someone who's into OAuth space, this should not come as a surprise, but here is the story. So we have the same base scenario, user trying to log in to the portal, protected with Azure Ready, let us say, or some identity provider. Now, like I said, each portal has some, in the Azure Ready, there are AAD apps. And in the AAD apps, per OAuth spec, there is something known as redirect URLs. Basically, with this configuration, what you're telling AAD app is, hey, once the user authenticates this is where you should be sending the token, right? Otherwise, how would Azure AD know unless we tell it? So where do we mention that? We mention it in the app for the tenant, for the directory. So developers, when they write code, right? So what we do is that, we have dev environments. The first one is prod, next test and staging and so on. After testing is done, let us say this domain is deleted, right? Meaning this website is pulled down. This domain is not available at all. But developers forgot to remove it from the AD app registration. Now what happens is, here we have an app where we have a URL where the tokens must be sent, but this domain is pulled down. It's available for registration by an adversary. So what happens is an adversary can check domain availability. Now how they can check, I will not cover here because that's more of a recon techniques. Let's say they check the first one and then say, okay, this one is a registered domain, but they find that the second one is an unregistered domain. So what they can then do, take over the domain, meaning what is take over? Literally register the domain, or in this case, create a Azure websites.net website with this exact item corp -test name. Now adversaries will deploy malicious code in this domain. Okay, see where this is going. Adversary found that a domain which is configured as a reply URL, it is not available. I mean, it's not registered. So they take over and then try to deploy malicious code and then send a phishing email to the employees. Now this is where it gets interesting. This is welcome to Auth Phishing. So this is the new generation phishing, in case if you are not aware of this earlier. Now, and now users, employees check the email. If they click the link, then through they go visit the attacker control portal, which is nothing but this test site. Now remember that attacker has deployed malicious code here. Now what then happens is, users, because of single sign-on, they, let's say, get authenticated to Azure AD, they would not even notice that a login prompt or a consent prompt is coming. Then the access token is now stolen by the attacker. So this actually scared and surprised a lot of developers, mainly because you see, I think as someone was saying in the earlier chats, developers really don't have time for understanding the nuances of protocols, and we should really empathize with them for that. Now, but however, so these are the kind of things that at least somehow there's a gap on how we translate this security knowledge to developers. And so this one, all it happened is that it's called a dangling reply URL. It was registered by the attacker, and then phishing was done, and the tokens were stolen. Now, okay, all this looks good in theory. Wow, this is nice. Okay, but what is the impact? How serious is this? We actually had a fair share of our problems. Thankfully, there were some responsible disclosures done on this, and we addressed and we fixed this problem, and we have a lot of scanners looking for this. But the point being, this is not some just a theoretical thing. This is a problem that developers must be aware of when dealing with OAuth. So then let's again pray for the demo cards, and let's try to see if we can get something done here. Okay, so let's now try to log in with a different identity, which is back to our CEO again. Now, what I'm going to show you, and hopefully it works, is the same scenario that I showed in the PPT. So what's happening here is that, the CEO logged in and they are visiting the site. Now, let us assume the attacker already took over the domain, they phished, they deployed malicious code, and then they sent a phishing link to the CEO. And this bookmark here, this is the phishing link. Let's just assume. I don't want to replicate the entire flow. Okay, looks like that's a bait. Something went wrong. So then let's see what happened. I got back something. Now I'm the attacker, right? So the attacker got back something. Now this is an access token, and it apparently says mail.read, which gives us some hint of a scare. So then let's go to a friend verb and then try to see what this is. There you go. So it's a 200 OK. And here is an email. So apparently this is from, here's the subject. it's a highly confidential email from the CTO talking about some kind of an acquisition. Of course, this is all fake scenario that I'm talking about, but I think now I think you can understand that there's an email. Basically, with this token, the inbox of the CEO is now disclosed. Now we can read the emails of the CEO, and we can now impersonate that person, right? So how did this happen? Now this happened because so we were able to steal this token as an attacker because the attacker took over something here. So what did the attacker take over? So if you go back to the app, that's what I was talking about earlier. If you go back to the AD app, okay, let's see. So these are all test and throwaway tenants, so I don't really mind if something is if I show something here. So if I show this app, if you see this is what I'm talking about. This is a reply URL that I've configured, but I forgot to remove as a developer. Now this, through some recon techniques, the attacker was able to find that this exists, and they were able to register this site, deploy malicious code, and because of OAuth, OAuth trusts that you configure your settings properly, and the token was sent to this, and that app had, apart from the API permission to my editum API, it also had permissions to mail.read, which is dangerous. So that's another takeaway. So the two takeaways here: one is make sure your reply URLs are you are owning your reply URLs, and two, make sure you're not over permissive about your app's permissions. Now, if this app has permissions to, here it has mail.read. What if it has permissions to your Key Vault or deploying to your Azure subscription, right? So you can see how scary it can be. So that is the second problem. Now, if you did not understand the entire workflow, that is fine. It's difficult to understand in a first shot, but at least if you are able to say that, wow, okay, there's some problem here, I think that is a key thing. Finding out the solution is the easy part. And of course, I'll also help with the guidance and other links in the PPT. That's the second demo. We have, I think, 30 more minutes to cover 3 more demos. I think they should be doable. I am not looking at the questions at this point. I'm sorry, I'll look at it at the end, but I'm hoping it is going on fine. So with that, next, let's move on to the code part. So far we have seen the two things that we have seen are mostly like half code, half config kind of a thing. Now this is pure code. From here, the next 3 demos are about code, and here is an insecure code. So in those like 6 lines, 5-6 lines straight, there are 3 vulnerabilities, and this is, and that's why this whole OAuth thing scares me a little, because if you are not really paying attention to what is going on into the code, I think there's a scare there. Now, what is this? Now, this piece of code that you're seeing here. This is ASP.NET, and it is authentication middleware. Now, what is authentication middleware? It is literally it's literally the series of checks that must happen when authentication handshakes are done. And the libraries that we use for ASP.NET and Azure AD is called MSAL. Again, I'm talking in the context of Microsoft Stack, but you can correlate. So basically, the libraries are having secure defaults, but these are configurations that override the secure defaults, to be clear. And these introduce 3 straight vulnerabilities. Now, we're going to talk about what these 3 things are. So first, let's talk about, okay, anyways, let me give a real quick heads up. So first thing is trying to say, hey, don't do signature checks. That's what this statement means. Because it's saying it's a delegate which just returns the token that came in. There's no validations happening. Okay, so this block says, don't do any signature checks on the token, which is really bad. Never do this. And then this second block here, validate if you're false, says, don't validate which tenant is giving me the tokens. Now, here's a catch. There are scenarios where you might need multiple tenants, tokens from multiple tenants. That's what we call as multi-tenant apps, right? If you're designing a multi-tenant service, in that case, this configuration makes sense. But if you are designing a single tenant service, meaning your enterprise app and only your enterprise users must access, this is a wrong setting to have, okay? And the third one, what it's saying is, don't validate the audience. Now, audience is a claim in OAuth. What does it mean? It means that if you're giving me if you're giving me a token, the token must be meant for me, meaning my API, and not for some random API, right? So if you set this to false, you're saying, okay, you're literally opening up token replace, token forwards kind of attacks. So that's the three things that we're going to talk next. So first one, the validate signature. The base case is this: user authenticating, getting back a token, and the tokens are signed by the identity provider, in this case Azure AD. And then what if there's a man in the middle who's trying to eavesdrop, right? So if they tamper the token, are you doing enough validations? If you are validating the tokens, sure, but if you are disabling validations like in the earlier sample, then you're going to have problems, and that we will see with the help of a demo. Now what we are going to do is, let's switch back to our demo mode. So I'm glad that the demos are going well so far. At least I hope. I mean, at least they did not crash. So let me sign out of this account, and let me try to log in with another account, which is dev001. This happens to be the developer. Okay, so now the developer is having access to this. Whether they should have access to it or not, that's a different question. Now, you could also assume that this is a compromised identity, right? So now what happens? Now let's do one thing. Let's try to turn on a burp interceptor. We're trying to simulate a man-in-the-middle attack here, trying to tamper, do the token tampering that I spoke about earlier. Now, if you're into bug bounties, this is pretty much a very common thing that you will look for and you must look for. So let's say I add something. Let me forward this because it's a CORS request, I believe. So then, okay, here, this one. And now I'm using an extension called Json Web Tokens. We just tries to encode and decode the tokens. Remember, the bearer tokens are base64 encoded. It has three parts: header, body, signature. So this little extension tries to ease my job of decoding it, right? So if you see, this is the developer dev001 account. Now, what I will try to do is literally tamper this and then pretend to be a CTO. I'm just saying, I'm changing the name, the UPN from dev to CTO. So then what I'll try to do is try to just drop message. Okay. Now let's see. Yeah, so I think that's pretty much it. And let's see how it goes. So now let's try to refresh this screen. Yeah. You see this dev elevated to CTO, and it shows the areas of CTO. Now, this is a very simple thing, right? So obviously it happened because in the code that I showed, right, the token signature validation is disabled. So then you can assume to be anyone else, and you can elevate if you are the adversary, right? So this is the other thing. So don't do that. Don't disable signature validations. So be cautious of that. So I think you're seeing how this is going. We're starting with a genuine account, then we're trying to see how guests can come in, token tampering, others can come in. We saw the phishing case where the tokens were stolen. Now let's continue that story with the next one. Is it issued by a tenant that I trust? Now, what is this? This is literally saying, okay, this app is in this tenant. Now the API must ideally check that, okay, I'm not a multi-tenant app. I just want I want tokens only from my tenant. So then there's this TID claim that the API will get. So the API must check that, okay, is this the same tenant that where my AID app is registered, right? So this comparison, this check must be done. Again, like I said, if you are using standard secure default libraries, they should be done by default unless you are trying to change the defaults. Of course, if you're not even using the standard or secure default libraries, and if you're doing all this on your own, then you have a problem because you might miss these checks. So what happens if this check is not there? Then the API is not doing this tenant ID check. So then the token can come from any tenant, and that could be your cross-tenant attack, which is what we are going to see. So now, the ideal case, if the attack works, is that we should be able to see one more entry here, not from the users of Editum Corp tenant, but with the user from the Fabricam tenant, which is a attacker tenant that I showed in the demo environment slide. So now for that, what we'll do is we will try to do a little trick in the interest of time, which is I will try to cheat a little. Well, not really cheat. Okay, I've already constructed a URL. So basically, when I'm talking about OAuth libraries and things like that, right? What they try to do is they try to construct URLs like this, which are pretty much what your identity provider expects. So I mean, obviously you can see what goes wrong if you try to construct all these parameters all by yourself. So that's why we rely on secure libraries. Now, what we'll try to do is now what this does. This is trying to do a login request so this is the tenant. This is the attacker's tenant. Okay, so we are trying to log into the attacker tenant with a attacker controlled app and with attacker's alias. Okay, so let's see. So I'll do this in an incognito window so that I don't mess up the sessions. Okay, I'm supposed to get this error, but I'm not really concerned about the error. What I want is in the URL, which is the access token, right? So I got back an access token that is in the URL. Now, by the way, this is what I'm using is called an implicit flow, which is not the most secure of the flows. So do not use an implicit flow. So okay, now this is the token that I have. So now what we'll do, this token right now that I copied is from the attacker's tenant. Now let's go back to Burp and let me grab a GET request and send it to a repeater. Now on this repeater, I have the GET request. So this token is the developer's token because I did not tamper yet or did not change anything. Let me replace this whole thing with the token that I grabbed from the attacker's tenant. Okay, I'll confirm by looking at the claims. So it says Haxer at Fabricam. So let me try to do this. So GET request succeeded, which means as the user from a different tenant, as the attacker, now I can do a cross-tenant request. Now let me try to do the other thing, which is post. So I will send this to repeater. I will try to replay this whole thing again. Now let me confirm first. This is all the previous traffic, right? So let me change this token to the token that I just grabbed and let me paste that. We'll confirm once more that this is from the attacker, right? So then what we will do is we will just leave a different message. And let's see. Okay, it's just 201 created. So now let's go back and refresh. There you go. Now you see this entry made by Haxer at Fabricam. Now this is what I'm calling as a cross-tenant attack. So ideally, it's supposed to come from your own tenant, but now it came from a different tenant, mainly because let's say the developer decided to ignore the tenant checks. Again, this is not supposed to be a multi-tenant app. This is supposed to be a single tenant app, but those checks were missing. So then the attacker can come from a different tenant with a different token, right, and reply against you. So that's how we are progressing. We came with a genuine user, with a guest, with a tampered account, with a account from a different tenant, a cross-tenant attack. So we saw 4 of them, and we have the last one, which is remember we tried to log in with the guest account and we blocked it, right? We blocked it at the client side of it. Now, when we talk about security, there's client, they're doing it's about doing security checks on the client side, which is bad, obviously, and then doing on the API side and the server side, right? So now we try to block the guest account on the client AAD app, but maybe there's a way to get in again. So let's see. So because the code decided, the developer in the code did not do audience check, let us see if we can use that to abuse our scenario. So what I'll do now is I will try to log in as the adversary, the guest account. Okay. Oops. Okay, I will try to log in. This time I'm pasting a different URL. Let me paste the URL first in this to show this. So this is actually the same tenant as the expected user. This is not the attacker's tenant. Okay, this is the Adatum Corp's tenant. But what you see here is that I'm coming from a different client ID, which means I'm coming from a different AAD app. Now we blocked the guest user on a different app, but now I'm coming from a different app. Okay, so so now the problem is, if this client ID is not being validated properly, then I mean, essentially this is the client ID part. This is what comes as a part of the audience claim. So if audience check is disabled, then this client ID check is not being done. Then that could translate into a problem. So let's see that. I'll paste this whole thing here, and I will try to sign in again. Okay, now again, as expected, this is supposed to be fail, but what I'm interested is in the token in the URL. Now again, let me grab the access token in the URL, and let's see what is there in this token. Again, I'll go back to our friend Burp. So firstly, let's inspect the earlier one, the earlier request. We use the attacker one, right? So now let's try to see, change this. Then go back and check. Now this is the token that we came from the guest account. So let's try to replay this. We got a 200, okay. So basically, though we blocked the guest account through a different app earlier, that wasn't the right mitigation, right? Because I told you it's the client side app, not the server side. So now what we'll try to do is come back again with the guest account. Let's check the claims once more. The claim says guest, right? So now let's then try to replay this traffic once more. 200 created, so 201 created. So then we go back, and it doesn't matter. I think we can log in with any account and check. There you go. So remember, guest was here. We blocked the guest through an AD app, but this time the guest came from a different AD app, right? So that is the app impersonation attack, or the confused deputy of apps. So all these things that we saw just now are the 5 attacks that I showed in the PPT. So I think pretty much, I mean, I'm glad that the demo guards are with me. So the demos at least did not crash. But that is the thing, right? So this is the audience check, because the API here is not doing this audience check. We can come in with an AAD app and get a token from a different app for this API, for a different API, and then just replay it. So that is about the demos. Now, I understand that this could be overwhelming and complex, especially if you're not into this place. So if you haven't done this in the past, I understand this could be definitely overwhelming, but I think the first steps, I learned it this way. The first step is that, okay, understanding that, okay, there's a problem, and okay, here is a way how it can be exploited. Then trying to dig deep into what exactly went wrong. Can I replicate it? Let's see the guidance, right? So it's a step-by-step process. So if some of you felt it's a little complex, but I think expect that in the OAuth space. But if you're into this space, I think you might have realized that these are all pretty basic things. So well, then sometimes there is guidance, but sometimes we misinterpret the guidance. So let's say, for example, there is this Microsoft Docs tutorial which says, hey, validate is false. This is simplification, but the point here is there's a clear guidance saying that do this only if you are talking about a multi-tenant scenario. Now, if we ignore that checks, right, a bunch of warnings, and we then try to blindly copy paste the code, we are bound to introduce cross-tenant attacks, right? And then sometimes we forget. Now, this is similar to some of the code patterns that we saw. We keep seeing this in forums and a bunch of other places, which is like signature validator to do, see if we can implement this logic, and then it just accepts and returns nothing, right? So there's no checks here. So that means you can, for this API, there is no integrity checks. So you can tamper the tokens and you can do all the elevations that I showed about earlier. So what it's all boils down to is, even though there are secure defaults, sometimes, either we try to, we do not understand it enough, or maybe we are not digging deep into it, right? So there are different ways. But one thing is for sure, if you are writing authentication middleware, even if it's secure defaults, please pay attention to what's going on into the middleware. If you are not using secure default libraries, then you have to be even more cautious, because similar to crypto, OAuth is hard. Like we trying to invent our own crypto routines and then claiming it to be secure. We all know how broken that is. So same thing in OAuth, we're trying to come up with our own token generation, token validation logics is bound to fail at some point if you don't know the nuances properly. So with that, I'll come to the conclusions, which is about really the high-level mitigations or recommendations. I have links to the reference slide, but I think at high level, I try to give a high-level guidance. Now, who can request guidance? Who can request tokens? We spoke about this as unauthorized guests problem. Firstly, see, again, the key thing is that it's not always bad that guests, I'm not saying that guests must not have access to anything. It's the heart of collaboration. But I think it's more about evaluating if guest or external accounts are the intended audience for your APIs. Like when you do your threat models, I think that's one of the questions to ask. Okay, who must be our audience, right? Who must really access it? Then try to do either tenant level policies or per application authorization checks, whatever suits your design. But I think that's one of the key things to ask in your threat model discussions. So second thing, the hygiene itself. So when we're talking about OAuth, obviously we're talking about a new territory. Like for example, we know about XSS and SQLize. Of course, that game also keep changes because of changing libraries and things like that. But OAuth is a completely new territory, and the hygiene of your apps, hygiene of your configurations, it's very critical that we periodically evaluate the hygiene. So check for reply URLs that are dangling or excessive OAuth permissions to sensitive APIs. So that's the key guidance there. Token integrity. Remember that when we are talking about federation, it's all about trust. We are trusting some identity provider. So then we are obligated to check that the trust is there by validating the signatures and doing all the crypto checks, and use secure libraries with secure defaults and don't modify that. And also don't roll out your own code for validating JOTs unless, I mean, I don't know. It's difficult to call someone as expert in this space, right? Because in peer reviews, it's obvious that many so-called experts will also be flawed. So don't roll out your own code. Crypto is hard, and use libraries with secure defaults and don't modify the defaults if you're not sure about it. And then the cross-tenant attacks. Yeah, I think this is another important one to call out during threat model discussions, which is understand your API design. Should it be single tenant, multi-tenant, and ensure that issue validation is done appropriately for your design. And is it for my API? Again, goes back to understanding your API design. Should it accept tokens of other APIs? I mean, I can't think of a scenario where this must be possible. But if there are genuine scenarios, I think that's where. So your tokens, your API must should ideally accept tokens meant for itself and not for others. So that is another key thing to take care. So yeah, so those are the 5 different problems that I want to talk about, and we looked at demos, try to understand the vulnerabilities, try to exploit it, and here are some mitigations. And one last thing before I wrap it up is we are hiring. That beautiful piece of art there is our team's logo, and go visit aka.ms/best team ever, which is our team, and you'll find more about the open positions in our team. And then here are the references. I will share this slide, right? You can see in the slide. And with that, I wrap it up. Thank you so much. I'm open for questions. So then let's go.
Thank you very much. That was surely perhaps the most authoritative survey and actual demonstration of each of the major vulnerabilities in the OAuth API I've seen. And it's really useful to see the technical pieces of it actually laid out right in front of us in a very well-structured presentation. Thank you for that, Krishna. I don't see any open unanswered questions in the chat so far, but several people have asked, will this be available on YouTube? And yes, we have recorded these and given details about that. I do see a question from Swetha. What can be the recommended permissions for the guest accounts in terms of access control?
So yeah, I think it really depends on the business and depends on the kind of environment it is. I mean, it's hard to say in a generic way because for some kind of enterprises, collaboration is everything, right? In that case, over restricting guest permissions is actually bad. So in some cases, you really want to restrict to a specific set of apps. So then the answer really is it depends and it varies. But yes, that's pretty much it.
Thank you. And we have a question from Venki T. Is there an API assessment you can suggest? As nowadays we are mostly on APIs.
So yeah, I mean, I don't think of this as a point and click tool kind of a thing. I think I think because this is getting into a specialized zone. Now playing around with OAuth tokens and is something that I think in general for pen testers, that's something that they should be really focusing on. There's yeah, I mean, there are some. I'm pretty sure there are tools for automatically scanning. For example, trying to submit tampered tokens and see how the APIs behave. Probably there's some scanners and things like that. But I mean, from my perspective, each solution is designed in a different way, and trying to understand the design and trying to see, okay, what is wrong, what is it, what can be done here. That's pretty much it. And I think the other thing is that that doesn't necessarily mean that we can't have any automation to find these things. There will be false positives if you don't understand the scenarios properly. For example, we can think of a code scanner, right? Like say, take your favorite static code analysis tool. Let's say, I don't know, CodeQL, some grep, and you can throw in your rules to find those misconfigurations in code. You might have false positives, but I think at some point in time, those can be fine-tuned for a per enterprise. So that's pretty much, I think that's pretty much it is.
That makes sense, and it's worth. It's clear from your description that some of the things that can go wrong are only wrong depending on the requirements of your application. Whether you need multiple tenants, whether you're supporting multiple audiences, there's some business logic that a tool would need to understand. I think that's it for the questions I see, and we're near our time. Well managed, just the right length. Thank you very much, Krishna. We really appreciate your expertise.
Thank you so much.
That will bring Krishna's talk to a close, and we'll have a little 3-minute break before the next talk starts at 12:30.
Thank you, everyone.